Hello students, how are you? Well, in the series of the electrostatics, today we are going to start the lecture number 3. Well, we have already discussed the basics of charge and Coulombian force. Okay, so today I am going to discuss something about that Coulomb force in vector form, and then if time permits, we are going to discuss electric field. Okay, due to point charge, due to line charge, and all. So it will be our today's agenda basically. So whoever is present, okay, so you please keep on commenting on right times, responding on the right time, okay, and all those students who have joined today only in my video, okay, so please do subscribe your our channel and push the bell icon so that you get the notification on time, because I'm coming almost every day at 9:30 p.m. Starting this series, okay, electrostatics, and for especially this is for 11 to 12 moving students. Well, so similarly we will start a series for 10 to 11 moving students also, but it will with time it will be okay. तो आज हम बात करने वाले हैं Coulomb's law in vector form. Well, so I hope everything is going fine. Well, here so if any queries, so immediately please write in the comment box. I think you can write to them. Yesterday actually it was not. I think today also. Let me check it once more. On the live session, whether you can comment or not. Okay, that's the thing. Well, just 1 minute. Okay, let us wait for 1-2 more students to join. Well, very interesting topic. Okay, and a lot of numericals also we are going to do. And all those students who have not that one attended my previous 2 lectures, please go for the videos, okay, already published, and of course it will be better actually, then only you can proceed, okay. Well, anyway, let us start, okay, let us start. Today's topic is Coulomb's law in vector form. Okay. After that we are going to discuss electric field also. Well, okay, hello students, all those who have joined now, okay. Today we are going to discuss the Coulomb's law in vector form, and to some extent about that one electric field also, okay. This is the third lecture. Well, so let me start it. Here, say we are having one point charge, okay. Say this charge is Q1. For convenience, I am taking positive charge only, okay. And its position vector is say R1, okay, from the origin, the position vector. So we can define the axis also. That is x-axis. So this is y-axis, and z-axis is say outward. Well, and we have some another charge at position vector say R2. Well, so we are going to discuss the force on 1 by 2 or 2 by 1, okay. So first of all, let me write force on 2 by 1, okay. So if we assume that they are like charges, so they will repel only, they will repel each other. So if I talk to force on 2 by 1, so 1 will repel it, means direction will be in this direction, okay. Force on 2 by 1. Well, so force on 2 by 1, it is given as, you see other part will be remaining same only, magnitude part will be, we know already we have discussed now, 1 by 4 pi epsilon naught Q1 Q2, okay, divided by separation square, okay. That is the separation, So in vector form you can write, if it is the separation, so R can be written as, you understand that R vector equal to what? R2 minus R1 only, okay. But here I need the magnitude, okay, because none can be divided by a vector quantity, only we have to divide by magnitude only, okay. So this much is square, R2 minus R1 whole square. Well, and the direction will be along this direction, Well, so you can write it as R1 to 2 cap, from 1 to 2, direction is from 1 to 2, as I am taking both are like charges, I am assuming like that, okay. If they are unlike charges, then of course direction, that arrow will be opposite now, okay. So first case we are discussing, that is for like charges, okay. Here actually you have to put the magnitude only, you cannot put the sign here, but direction depends upon whether they are repelling or attracting. Here they will repel, so obviously direction will be this way. And for this particle, of course, in this direction, it will be discussed later, okay. So this is one form, okay, vector form, or if you want, if you can write in a modified form also, this can be written as 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 whole square, okay, into that R cap is nothing but R2 minus R1 vector divided by its magnitude only, okay, R2 minus R1. Well, or if you want, you can rearrange it also. So if you rearrange it, you can write F21 is equal 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 whole cube R2 minus R1 vector, okay. Remember why the whole cube? Because here you see, here also R2 minus R1, and here it is R2 minus R1 whole square, no? So altogether it will be R2 minus R1 whole cube, and numerator is what? R2 minus R1 already there, vector, okay. So for calculation purpose now, this will be the best that one expression, okay, for numerical problem solving. This is the force on 2 by 1, okay. Remember, if you write this part, R1 minus R2, then also answer will be same only, because it will be magnitude, no? So magnitude will not change, but this part you cannot change, okay. It will exactly give the direction of 1 to 2, because if it is the R2 vector, okay, if it is the R1 vector, then R2 minus R1 is this only, okay, that is R2 strictly. If the resultant is in opposite direction, then it will be R1 minus R2, okay. So say we are going to calculate in the second case, force on 1 by 2 means F12 we are going to calculate, okay. If you want to calculate F12, so everything will be remaining same. Well, Q1, Q2. And this part actually if you want you can change, or if you don't want then also no problem, okay? Because it is magnitude only, but remember this part definitely should be changed, okay? R1 minus R2. R1 minus R2 is negative of that only, R2 minus R1. Well, say this is equation number 1, this is equation number 2. Well, so you can understand that as R2 minus R1 equal to negative of R1 minus R2. No? So it means what? You can prove that F21 equal to minus of F12. Okay. That is also the thing we have already said in our previous classes, that Coulombian force is action reaction pair only. Okay. So this is 1, this is 2. If 1 repels with a force this, then 2 will repel with same amount of force, but direction will be opposite. Value will be same, but direction will be just opposite. Okay. So that thing also we should understand. Even we can prove also. Well, we can do numericals also from this. Okay. We can do some numericals also from this. No problem. ठीक है? I think today also there is problem in commenting. Anyway, up till now, please go through it, try to understand whatever I have said. Okay. Well, so let us have a small mathematical problem. So please try it. Just simple problem. Okay. Please try it. The electric force on a charge Q1 due to Q2 is 4I minus 3J Newton. What is the force on Q2 due to Q1? Well, simple. Just get the logic. Well, so answer will be very simple, okay? Because I have already discussed it is action reaction pair only. Force on 1 due to 2, it is given as 4I cap minus 3J cap, okay? But we want F21, force on 2 by 1. We know that this is equal to negative of F12 only. So it means answer is just minus 4I cap minus 3J cap, okay? Simple, this is the answer. If can break it also if you want, no problem. That is different issue. But answer is simply this one. Well, we can have a another numerical also. Let me frame it. Let me frame one numerical. Say two particles of charge q1 equal to 2 coulomb, q2 equal to say 3 coulomb, means both are like charges, okay, and that first particle is positioned at say position vector whose position vector is RA equal to a I cap plus j cap, and the second particle is positioned at say 2 I cap plus 3 j cap, okay. So I want force on 2 by 1 in vector form, okay. You also please that frame it, try to solve it. I want in the vector expression, okay. Two particles of charge 2 coulomb and 3 coulomb are located with position vector I cap plus j cap and 2 I cap plus 3 j cap. So what is the force on 2 by 1, okay. It is read like that only, okay. Force on 2 by 1. You can visualize it also. The picture can be visualized also in the same way I have discussed. That is y, that is x, okay. Say first particle is here, that is q1. Say second particle is here with position vector r2. As both are like charges, I want force on 2 by 1, so direction will be this way only. So r2 minus r1 I want. So from that only you can easily calculate. First r2 minus r1 you calculate, that is 2 minus 1 is I only, that is 3 minus 1, that is 2 only, okay. And so r2 minus r1 vector is this, so its magnitude will be what? 1 square plus 2 square. So it means under root 5, na? So from that we can easily calculate force on 2 by 1, na? It is equal to what? 1 by 4 to 9 into 10 power 9, and q1 q2, that is 2 into 3, well, divided by r2 minus r1 whole cube, well, which is under root 5 whole cube, means 5 to the power 3 by 2 into r2 minus r1, okay, that part only. So if you little bit simplify it, okay, 3 into 2 6, 6 into 9 54, okay, whatever you can simplify, you do it and you get the answer, okay. Well, remember up till now whatever we have discussed, we have discussed for like charges, either they are positive or they are negative, and shall be same only, okay. But if they are unlike charges, okay, there will be a little difference in the expression. So let me discuss that also. If they are unlike charges, okay. So then what will happen? That is case 2. Again situation, let me draw the graph, sorry, that one, coordinate axis, xy, say this is q1, say it is negative at position vector r1, at position vector r2 we have another charge particle, say q2, which is positive. Well, so what do we want? Say force on 2 by 1 only, okay, same thing as we have discussed earlier. Force on 2 by 1. So other parts will be remaining same only, 1 by 4 pi epsilon naught q1. Remember here it will be q1 only, not minus q1, okay, because here always I have to put magnitude q1 q2 by separation. This separation you can write r2 minus r1 also, r1 minus r2 also, but I will write here r1 minus r2. Why, you will understand, because you see this negative charge will attract this, na? So direction of force will be in this direction, okay. In this direction the vector is r1 minus r2, not r2 minus r1, okay. We hope you have discussed in in the vector chapter. That is why R1 minus R2 I have written whole square, well, into the unit vector, okay, unit vector along this line. So that is nothing but R1 minus R2 divided by magnitude of it. Okay. We have already discussed in the previous part also. So if you want, you can little bit simplify it. 1 by 4 pi epsilon naught Q1 minus Q1 Q2 by R1 minus R2 whole cube R1 minus R2, okay. That is for unlike charges. You can compare with the previous expression. It is again that minus 1 difference only, okay. In the previous expression you got here R2 minus R1, but here it will be R1 minus R2. And exactly said that way, F21 I have calculated, F12 also we can calculate, force on 1 by 2, okay, F12. If I calculate F12, then just the direction will be different, nothing else, Q1 minus Q2. And I have already told you this part, whatever I am writing now, well, if you by mistake if you change it also R2 minus R1 also, there will be no problem, but because it is magnitude. But remember this part should be exactly same. So now this will be R2 minus R1 because direction will be opposite. Na? For this force on this charge, the direction will be this way, na? Because it will attract. Na? That is why. So these are the two expressions for unlike charges. Well, so that way you can do the numericals, no problem. Well, so let us move to some that one. Up till now actually we have discussed the Coulombian force between two charged particles, well, and the superposition of forces also we have discussed. Well, we have discussed that one vector form also, well. So later we will practice it, okay. Wherever I have put box, there are some important that one results which can be used for calculating number problems, okay. Now let us discuss the force due to some continuous charge distributions, okay. If there is some continuous charge distribution, say you know the force between these two charges, okay. Say that is Q1, that is Q2, you know what is the force. But if this is not a point charge, say this is a continuous charged body, okay. So what will be the force on it? So what will you do? At some r distance, you will take a infinitesimally small differential element, well, where charge will be dq2, and this will behave like a point charge because it is very small length. So for that you will calculate df, force between this small charge and this point charge. Obviously it will be very small, so it will be k means Coulomb's constant, okay, 1 by 4 pi epsilon naught dq2 into q1 by that r square, okay. And if you integrate it, you are going to get a total force. But remember, while integration, we have to take care of the direction of force also, okay. So I am going to take one example, and I am sure after that example, k can be taken out of the integration. It is a constant only as far as our situation concerned. But if it is not, then of course we have to integrate it with proper way. Anyway, this is the simple that one way of doing, okay. So let me take one example, so that there you are going to get it clear, okay. Let us discuss. Force due to a charged rod on a point charge placed along its length, okay. We are going to derive it. Say we are having one charged rod, okay. Say it is having positive charge. Say charge is Q, uniformly distributed, okay. Say length is L. Now from this rod, at some that one, say r distance from one end, one point charge is there, say Q naught. Well, so what is the force given by the rod on point charge Q naught, or what is the force given by the point charge on the rod? Okay, same thing, value will be same, just direction will be opposite only. Well, we are going to discuss it. Remember, they are not point charges. So if they are not point charges, so directly we cannot use the Coulomb's law, but we can make a that one arrangement so that we can apply the Coulomb. What is that arrangement? What I do here, from this point charge, I take a differential element, okay, very small element of length dx, which is at an x from this point, okay. as the length is very small, so charge also will be very small only. At this, it will be behaving like a point charge. So I know the force between this point charge and this point charge because it is coming from Coulomb's law only, and force will be very small because point charge dq is very small, so force also will be very small. Okay, so it is nothing but Coulomb's constant dq into q naught by separation. Separation is x, not r. Okay, because at a x distance we have taken distance, so that is x square. Well, simple Coulomb's formula we have used. So in the left side only one variable, that is force. On the right we have two variables, one is capital Q or another is x, no? Because if you take this segment here, obviously x will also be different, no? X is variable, Q itself is variable, dq. Total dq integration is Q only altogether, total charge. Anyway, let me convert into single variables. Okay, so here I put x square, that q not taken out. That dq part can be written as, you see, dq part can be written as the density is uniform, so q by L is the total charge by total length. That can be written as dq by dx, because dq is small charge, dx is corresponding length. Okay, depth ratio and q by L ratio, that is also called even lambda. Okay, charge per unit length we can say, that will be same only. So from that we can say dq equal to q by L into dx, which I am going to put here. Okay, q by L dx. So q is constant, L is constant, they will come out of the integration. So let me put this apart. Okay, so dx upon x square is left, integrate. So what is the lower limit of x? You see that dx element can be taken from here to here only, no? So if it is taken here, the x is nothing but r only, and if it is taken here, the x is nothing but r plus L. Okay, so it means integration should be performed from r to r plus L. Okay, and here it is correspondingly 0 to f. So if we little bit simplify it, so k q naught q by L, 1 by x square is nothing but minus 1 by x only. Okay, we have to put the limit from r to r plus L. No? Calculation part you can do. Before I complete, I am sure you are going to complete it. So f is equal 1 by 4 pi epsilon naught k, putting the value, that expression k. Okay, q naught by L, q naught by L. So if I put the limit here, okay, you can interchange the limit if you remove the minus sign. So 1 by r minus 1 by r plus L. Okay. So f is equal 1 by 4 pi epsilon naught q naught by L, r into r plus L minus r got cancelled. Well, and even LL also will got cancelled, na? Because in the numerator only one L will be left. So finally you are going to get the expression 1 by 4 pi epsilon naught q naught by r into r plus L. Okay. So this is the, actually you can say that one way, this is the final answer. Okay, this is the force given by the line charge to the point charge, or by the point charge to the line charge. Well, so just direction will be different, magnitude will be same. And you can even check the validity of this expression. Validity means the correctness of this expression also you can check. You see, if say L is very very less than R, okay, it means the charge can be assumed as a point charge only. Okay, if this length is very very small, it means it will behave like a point charge only. Well, so what will happen here? You see, in this expression, f is equal to 1 by 4 pi epsilon naught q naught by that r plus L will be r only. So r into r is r square. So it means it is the two charges will behave like two point charges. So for point charge formula is correct. Okay. So it means it supports the correctness of the that one answer. Na? Well, okay. So I hope you are getting it till now. Good. Then that is actually what using the basic that one relation of force between 2 point charges using Coulomb's law, we have derived the force between a line charge and a point charge. And even we can calculate the charge between a ring and a point charge also. We can derive that also. Let me try it. Well, force on a point charge placed at the center of uniform charged arc. Say we are having a arc. Say this is the arc. Even in the previous question, one more thing. This expression can be written in terms of lambda also. So we should learn that expression also. This expression can be expressed in terms of lambda also. Charge per unit length format also. So let me actually write that part also. So here you see in this question only you have got 1 by 4 pi epsilon naught q naught by r into r plus l. Well, that the expression we have already discussed. Now you see that q can be written as lambda into length, because you see this is a rod. Well, it has charge q, it has length l. So lambda equal to what? Q by l. So it means q can be written as lambda into l. So our expression will be coming in terms of lambda. So that should also, because in many times that it is given actually, that is why. In many times in the question it is given like that only. So lambda into L, q naught. Well, so in terms of lambda it will be So we should know that also. And in this problem, you see, force on a point charge placed at the center of a uniform charged arc. Say this is a positively charged arc. Well, I am taking positive only so that it will be easier. No problem. You can do it for negative also as well as positive negative charge system also. Say this is the center of the arc. Say the arc angle is alpha. Well, say the arc radius is r. Say the charge density is lambda. Well, you can even express in terms of lambda also or in terms of charge also. Both the answer I am going to give. And at the center, say we have a point charge q naught. Well, so what is the force given by this line charge on the point charge, or what is the force given by the point charge on the line charge? Everything will be equal and opposite. No need to worry about it. So how to derive it? Because you see, we don't know for this line distribution, but we know for the force between any point charge. So we are going to take the advantage of that. Well, so what I do, at some theta, I take one very small segment of angle d theta. Obviously, the charge here will be very small, dq. Well, in fact, this length also will be very small, dl. We can write, or you can write dl equal to r d theta also, because you can use arc formula. This is dl. Well, and that is theta, and that radius is r only. So from this arc formula, we can write dl equal to r d theta also. Well, so this is also positive charge, so it will repel it. So it means the force direction will be this. Well, so if you extend this line, so by geometry, if it is theta, so this angle also will be theta only. This component of force will be dF cos theta, and similarly we are going to get a component here which is equal to dF sin theta. So by symmetry, you can see if you take a dq component, dq element here also we are going to get a dq element. So it means you are going to get a df sin theta component here. So df sin theta will get cancelled. Only the net component will be along that df cos theta. So net force will be what? Net force is nothing but df cos theta only. And what is df? df is the force between dq and q naught. So which is equal to K dq q naught by r square. R is constant, radius is constant, into cos theta. Okay. So whatever constant you can take out of integration. K is constant, q naught is constant, r square is constant. Okay. So dq is left. dq can be written as, you see, total charge. If the total charge is q, well, total angle is alpha. So you can write q by alpha is the charge per unit angle into your angle, okay, d theta. So this is the nothing but the charge here into cos theta. Okay, means total charge by total angle. So charge per unit angle, you got it, into d theta. D theta is that particular angle in which your element is there, dq. No? So we have to integrate it, nothing else. So again q and alpha is constant, so it can be taken out of integration. So r square capital Q alpha integration of cos theta d theta. Okay. So what will be the limit? You see, you have arbitrarily taken here. So if you take this element here, so theta will go in increasing. If you take the element here, so theta will be alpha by 2. So similarly, if you take this element here, so the angle will be minus alpha by 2. So integration should be performed from minus alpha by 2 to plus alpha by 2. Okay. So it means you can say that f equal to k q naught by r square alpha. So cos theta d theta is nothing but sin theta only. Okay. If you have to that interchange the limit also. Cos theta. So sin theta, that sin alpha by 2 minus sin minus alpha by 2. So it means 2 sin alpha by 2. Well, so ultimately this is the expression in terms of that one, alpha or and q. Okay, that is the total charge. And one more thing, you can just visualize also. You can also find the validity, the correctness of this expression. How? See, if it is a complete ring, alpha will be 2 pi. Na? If it is a complete ring, so alpha will be 2 pi. And of course, then the force should be 0, because it will be symmetrically repelled from every segment. Na? Okay. So let us check it. If it is 2 pi, so 2 pi by 2 means pi only, and sin pi is 0, automatically force also will be 0. Well, so it means it supports that correctness of the answer. And if you, I can do it, no problem. So here f is equal k can be written as 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. Q can be written as that Q part, Q can be written as, you see, lambda into length. Okay, lambda into length. Length is nothing but r alpha, because you have the radius is r and the arc angle is alpha, so length is what? R alpha. Well, and into Q naught divided by r square alpha into 2 sin alpha by 2. Okay, calculation part you can check it. Into 2 sin alpha by 2. So now you have to just little bit simplify. That alpha got cancelled, 1 r got cancelled. So f equal to what? Lambda q naught by, this can be neutralized to 2 pi epsilon naught r, well, sin alpha by 2. So this can also be answer, because I don't know in which format it will be there in the question. Thus you can understand both. Well, so I hope you have understood all these things, whatever discussed. Okay, so I think we should end up the video today here only. Okay, we are going to discuss the field part in our next class. Okay, tomorrow we can discuss the field part. So whatever we have discussed, we can give a quick review. Okay? Uh, so at the beginning we have discussed the vector form. Okay, vector form between two like charges. Then we have discussed vector form between two unlike charges. Well, that is for unlike charges. Then we have done one numerical also. No? Well, then for that charge distributions, okay, continuous charge distribution, force between a conductor, charged rod and a point charge. Okay, we have discussed all these things. So in the next class tomorrow at 9:30, we are going to discuss about that one electric field and all. Okay, today we are not going to discuss. Start it. So tomorrow we are going to start it. Okay, electric field. Well, then we will be going for that one coulombs, that one Gaussian and all also. So up till now, actually, we have discussed an introduction part, electric charge, conductor in an insulator, basic idea. Okay, charging a body, we have discussed Coulomb's law. Okay, so tomorrow's class we are going to discuss electric field. Well, so please, dear students, if you are whenever you just go through any numericals we discuss, so first you will try, then write your answer in the comment box. And also please do subscribe my channel if you are not subscribing till now, and invite your friends also to join, okay, and take the maximum benefit of it. Well, uh, so thank you. Thank you. Bye bye.